Hello, I'm Joris from Group 11 of Interactive Intelligent Products course of 2020, and I'm here to introduce our product ShortKi. In the past few years, many new smart devices have been introduced on the market with the goal of easing people's lives, such as Internet of Things, smart assistants, and system automation or home automation. Furthermore, for many digital professions, for instance, such as digital artists or programmers, the amount of control needed over your devices, which are becoming more and more complex, is paramount to the efficiency of the work they do. Their work depends on the use of repeated instructions, which can be optimized. We want to provide a new way for people to control their workflow or other IoT systems in their home or work environment. ShortKi is an independent program running as a background service on your computer and listening for gestures, so human-made gestures that you make. The user can configure these ShortKi gestures and actions and link them together. The main feature of ShortKi, which we are going to demo, is the PC ShortKi ability. But ShortKi also has IoT data support. In combination with systems such as Home Assistant, IFTTT, or Philips Home, you can easily link gestures with your home systems, such as lights, doors, windows, you name it. So here you can see a user switching between different applications. So he's working on a project in Photoshop, but with a gesture on his hand, he can switch to things like his web browser, or switch back to Photoshop on a project he was working on. And now he has complete control over his own workflow. He can open settings if he wants with a gesture because he linked it previously in his app. And he can do a lot of different things which he himself configured so he can optimize his own workflow. The sensor data we use comes from an accelerometer. The input features, the X, Y, and Z rotation of the 6-axis accelerometer are collected using Arduino and processing. We process the data using Weka and process it to an ARFF dataset, which we then use for creating the first prototype of the model. Or learning algorithm, and for learning these features of the gestures, we have used the KNN, or the nearest neighbor algorithm, since it offers a lazy learning algorithm, which means that we can update the dataset continuously with new entries. So a user himself can add or subtract entries of their own dataset. This comes with a higher computation cost at runtime, but it gives the users complete control of the gestures they want to link to certain actions, and they don't have to choose from a predefined set of gestures. To determine the optimal K, parameter for K, we use the elbow method by plotting our within cluster sum of squares, also WCSS, against different values for K, including to a good value of K equals 5. The in-sample accuracy of our test dataset in our prototype was 100%, and an estimated out-of-sample accuracy of 95%. One problem that arises is that the system always chooses to do an action. So when two gestures are very similar, it will still choose between one of them and trigger the attached action to the gesture. A more friendly or a more user-friendly solution is to implement a confidence system that prompts the user when two gestures are too similar and the system is not confident enough. Currently, the interaction is limited to only still frame gestures, and we would like to explore a bit more as to which interactions are possible. The system also has a quite small footprint, so it can be run on smaller devices or even on embedded systems. The limitation here is again due to our lazy learning algorithm. It's the time needed to process a ShortKi or to predict an action. Future steps of ShortKi would be to create a 2.0 version. It will support linear accelerometer axes, so also moving gestures. Also creating some different types of wearables for the user to wear, like rings that the user can interact with the system with, or even artists use the artist glove on drawing on digital pads, which are already things they use, and we can integrate our system with already made applications.